Welcome to Homework Lib.
Hi, so in this case we have the following equations that are HBr plus calcium hydroxide to equivalents that are going to react in order to generate calcium Br2 plus two equivalents of water. First of all, we need to balance this equation. This can be done directly simply by multiplying the first compound by a number 2. And we are asked to get the net ionic equation for this reaction. So how do we find the net ionic equation? Well, we're going to deal with separating the ions that we have on each of the sides accordingly to the stoichiometric relationships that are present for all of them. Br minus plus 2 equivalents of water. Of course, water is not going to ionize in any way. Remember that this H plus is a placeholder for H2O plus actually, because HBr, when it gets into contact with water, is going to generate H2O plus Br minus. Okay, but here I'm just using H plus for sake of simplicity when we do the separation of the ions in our net ionic equations. But we can always go back and put it as it should be, H2O plus. So now, in order to get the net ionic equation, we're going to cancel things that do not react and they stay the same on both sides of the equation. For example, calcium 2 plus stays the same, bromine stays the same. So the net ionic equation in this case will be two equivalents of H2O plus two equivalents of OH minus, producing two equivalents of water. Now, for the next reaction, we're going to get calcium hydroxide plus HClO4, another strong acid, that is going to react in order to produce CaClO4 2 plus two equivalents of water. So here we need to balance this out. This can be done simply like this for this new equation, and we can follow the same procedure. But this time around, we can actually skip some of the steps. Here we're going to get calcium 2 plus 2 of OH minus, plus 2 H plus 2 ClO4 minus, producing calcium 2 plus 2 equivalents of ClO4 minus, plus 2 molecules of water. And you're going to realize that the net ionic equation is going to be, at the very end, the same as the first one. And finally, for C, things are going to change a little bit. Now we have potassium hydroxide plus phosphoric acid, 3PO4. In this case, we are going to get potassium phosphate plus water. And now, how many waters we are going to generate? 3 molecules of water. We have 3 potassiums, so over here we require a number 3. You can check it up. That the equation is balanced. We have 6 hydrogens on each side, 3 potassiums, 1 phosphate on both sides, and everything looks good. So now the net ionic equation coming from this would be 3 of K plus 3 of OH minus plus 3 of H plus. Again, remember this is a placeholder, plus PO4 3 minus, producing 3 potassium plus PO4 3 minus, plus 3 equivalents of water. And you're going to see that the net ionic equation after we cancel everything out, it is going to be simply this neutralization.